GFS is a distributed file system, which means that it's a way for us to store data over the network in multiple places that is fault tolerant and resilient, which means that if one of the machines we have breaks, then the rest of the system keeps working. So it's a reliable way to store large amounts of data. The other cool part about the Google file system is that it's scalable, ideally. So that's actually what we did, because we had Amazon gave us a grant to test our program. 240 virtual machines all running Google File System for us. And it worked just as well as it works in the lab right now.
When everyone's working on their own projects, they get it to work individually the way they designed it to work. But then having everything integrate together becomes a problem because one person says it should work this way, but then the protocol that another person has is a bit different and usually ends up in a lot of bugs and issues that aren't always straightforward to resolve because they're subtle. I think in its current iteration my plan is primarily in physics, mathematics, and computer science, but it also incorporates architecture and design into it. But the idea of architecture really isn't just about designing buildings, it's about design in general, making sure things work in a way that is conducive to movement or to light, to space for people, essentially. And in a similar way, code is the same. You want it to be structured well, you want it so other people can read it, so other people can fix it. And so you don't want things like bad communication between components or between members of the group to cause faults and errors in the program itself. You want everything to run smoothly, and the best way to do that is to design before you actually start implementing. I think architecture, at least for me, has helped in realizing how to approach the design process.